Here we will be demonstrating how to sketch graphs for 4 equations, 2 linears and 2 quadratics. The reason why A and B are called linear is because the exponent, the maximum exponent above the variable is 1. And the reason why C and D are called quadratics because the maximum exponent is 2. Okay, 2 for quadratic. Quadratic is 2 quadratic equations. Now, basically, we are going to use an online software to do that. Very simple. So let's start with A. So basically, you copy this, Control C, you go to a new tab, and you can type free online graphing calculator. There it is. And you'll get different varieties. You have Desmos, you have NumWorks, you have GeoGebra, okay, you have Symbolab, okay. Symbolab somewhere over down there. There are numerous of them. There are many of them. Probably can use different ones for each one of them just to demonstrate, and just type Control V, and voila, here you have your graph. Okay, and all you do is you can adjust the zoom, and I think you can adjust the labels. Okay, basically, let's say you want from -4 to 4. Yeah, you can experiment with it, and you can use your snipping tool and take a snapshot, or if you have a different method of taking a snapshot of your screen, and then you paste it in your book. And that's it. That suffices. This is the x-axis. The limitation of this one, it does not show the x-axis, and the y-axis is the vertical axis. Okay, probably might have to scroll along right on the other side. So we'll use another one that shows that the vertical axis is the y-axis and the horizontal axis is the x-axis. And this line is showing the behavior of the y values. So anytime you see a line, it shows you the behavior of the y. The x is always increasing from left to right, but the y can be increasing or decreasing as x is increasing. So for this one, as x is increasing from left to right, y is increasing also from down to up. So let's move on to, oh, and that's why the gradient here is positive, is a +5. Okay, the +5 means that each time the x increases by 1, the y increases by 5. You may see better here. Each time x increases by 1, from 0 to 1, y increases by 5. Look here, from 0 to 1, 0 to 1, 0 to 1, y increases by 5. And the y-intercept is where the line touches the y-axis. That's where x is 0. So y is equal to -3 when x is 0. That's the y-intercept. So you plug in a 0 there, 5 times 0 is 0, y will be -3. So that's the interpretation of the y-intercept. Now, I purposefully made B now with a negative gradient. Gradient is -2. So as x increasing by 1, y decreases by 2. That's what this -2 means. As x increases by 1, we always interpret the gradient by saying x increasing by 1. And the gradient will show you how y behaves when x increases by 1. So as x increases by 1, y decreases by 2 here. Up there, as x increases by 1, y increases by 5. Y also increases, but by 5. So for this graph, we should get a line that more or less is going down because x is decreasing by 2. So let's use a different software. There are a variety of them we can choose from. Let's try this one. Well, this one looks a little bit complicated. Let's use GeoGebra. It. Oh. So I have to type in y is equal to -2x. So you see y is decreasing because of -2x plus 8. So it is the y-intercept. So as you can see, as x increases by 1, y decreases by 2. So you can see clearly here, x increases by 1, y decreases by 1, 2. X increases by 1, y decreases by 2. And it starts at 8. So we put the plus 8 there. And as you can see, it starts at 8. That's the y-intercept. This one comes with the arrow, so it's more user-friendly. But it still does not label the x and y axis. Just put an arrow there. But it shows you a little bit clearer the behavior of the gradient. I have cropped this one. Let's say if I put a 3 there, and I change the y-intercept to 2, for example. Right, so this one, as you see, as x increases by 1, y increases by 1, 2, 3. That's the gradient starting at 2. X increases by 1, y increases by 3. X increases by 1, y increases by 3. That is the interpretation of the gradient. And we can simply paste this there. We can reduce this in size so that it fits in. 2 in a page. Increase this one in size so that it fits in. Right. And let's move on to quadratic. Now, the quadratic now is not going to give you a straight line, it's going to give you a curve, which is called a parabola. Okay. Y is equal to 3x squared plus 2x minus 6. Three x squared. To put the square, you can just type shift and number 6. That's where the upward arrow is to show you the square. 3x squared plus 2x minus 6. And here's the parabola. Parabolic shape is a curve that has a minimum value. It is symmetric, can follow itself, and it fits in nicely. And it is concave downwards. That means it has a U shape because the coefficient of x squared is a positive number. So it has a U shape, and it's a characteristic shape, and it's called a parabola. And the gradient is changing at each point. Okay. As you can see, the gradient here is negative. As x is increasing, y is decreasing. but the gradient on the right side now is positive. As x increasing, y is increasing also. The gradient at the minimum point is 0, because at the minimum point, y is not increasing, neither decreasing. Y is changing direction from going down to going up now. So at the minimum point, the gradient is 0. Meaning y is not changing at the minimum point. So here we have a parabola, a U-shaped parabola, because the coefficient of x squared is positive, and I purposefully made it D with a negative coefficient of x squared, so that we're going to get the other shape of the parabola, which is an N shape, minus 5x squared plus x plus 3. Minus 5x squared plus x plus 3. So now we've got an N-shaped parabola. There it is, which has a maximum point. On the left side, y is increasing as x is increasing. But on the right side now, y is decreasing as x is increasing. X is always treated as increasing from left to right. The line that you see shows the behavior of the y variable. Okay, the dependent variable. The y variable is called the dependent variable, and the x variable is called the independent variable. So here you have it, using online software. And you can experiment with other softwares. You can use Symbolab. Symbol, S-Y-M-B-O. Here it is, Symbolab graphing calculator. And it can be used also.